So P is true, Q is false according to the question, and R is true. Find the value of P and not Q. So let's start with that. So P and not Q. So we have what Q is. Q is false. That means not Q is going to be true because it's the opposite. So P and not Q are both true. So that means we get to put a T here. Okay? That and symbol means they need to both be true. And then we also need to find out this truth value, that P and not Q implies R. So in order to figure that out, let's actually first start with P and not Q. Oh wait, we have that, sorry. That's what we just did. Now to find out if this is true, the first part of the conditional statement, if it's true, then R must also be true for us to put a T under here. So P implies not Q. This is true according to our truth table. And R is also true, so we get to put a T. If P implies Q is false, it doesn't matter what R is, we'd put true here. And if P implies Q is true, but R was false, we'd put F here. Okay, so they're both true. That looks like our winner. This one's a little trickier. P and Q, so it's like kind of doing a partial truth table. P is true, and Q is false. We're supposed to find P implies Q. So in order for this to be marked true, P would need to be false, and then you automatically mark it true. Doesn't matter what Q is. Or they both need to be true. P is true, Q is false, so this gets marked F. So we just found out this truth value is false. And so it doesn't even matter what Q is, right? Because if this is false, the AND statement is not true. AND means they both have to be true. So this first one is false. This is F. And so that means we can scratch this option out because it says it's true. Scratch that option out. We know that P implies Q and Q is false. And so now we're supposed to find this is nuts. P implies Q and Q, which we just found out is false. See if that implies not P. We get to automatically mark this as true without even thinking about what not P is, because if the first part of the condition is false, it's automatically a true statement. So false, true. That's this option right here. Let P be the statement 17 is greater than 13, so P is true. And let Q be the statement 13 is greater than 19, so Q is true. And let R be the statement 9 is greater than 17, that's not true. What is the truth value of not P? Okay, so before we go on, the negation of P is F. It's false. If P is true, the negation of P is false. And we're supposed to find not P and Q. So not P is false. That doesn't matter. That means it doesn't matter what Q is, because for this to be true, they both have to be true. Oh, and then we got to do not P and Q implies R. So not P and Q is false. That means this statement is true. Then we also have to do R implies not P and Q. Because it's biconditional, you got to consider both options. R is false, so the first part of the condition is false. That means this gets marked true. So the biconditional, doesn't matter which way you go. If you go this way or if you go this way, we just found out they're both true. So the truth value in the end is true because the biconditional holds.